I see the participants, so I'm going to start with an introduction of Christine Kirkpatrick. Christine oversees the San Diego Supercomputer Center's Research Data Services Division, which manages infrastructure, networking, and services for research projects of regional and national scope. She founded the US Go Fair office at San Diego Supercomputer Center, which actually had a great role in moving forward fair data standards for the New Mexico Water Data Act. So that sort of came close to home. She's a principal investigator of the West Big Data Innovation Hub, the Open Storage Network. She's PI of the EarthCube office, which is ECO, and co-PI on the new ExcelNet award that you'll hear about transboundary groundwater research. She serves on the technical advisory board for Research Data Alliance, the external advisory board for the European Open Science Cloud, Nordic, and the National Academies of Sciences U.S. National Committee for the Committee on Data, CO Data. So I just like reading that. It's so great to hear everything that you're up to, Christine.
Thanks so much, Sam. Yes, so I'm honored to be here today and honored to be part of this group working on, I can't think of anything more topical than resiliency with groundwater. And this is a long time coming that we wish we could be together in person, and we will be again. With that, I'd like to hand it back to Dr. Sam Fernald, who will kick us off.
Thanks, Christine. I have 1 minute. I timed it. So good morning again, everybody. I would like to take that minute to give a high-level snapshot of the importance and excitement of this topic for me. I'm the PI on a newly funded NSF project that seeks to build a network of networks involved in research to make transboundary groundwater more resilient. One of our team's fundamental beliefs is that we need to equally include human and natural systems to understand and manage transboundary groundwater. Our de facto logo links hydrology, system science, data science, and social science. We feel that with exciting new modeling and data techniques, we can bring together research on hydrology and society to make an important contribution to transboundary groundwater science. There are so many experts here at this meeting with a wealth of knowledge and experience. We hope to bring together their breadth of understanding in an integrated system approach to groundwater resilience. The challenges are great, but the potential benefit is huge for improved water resilience in our region. Back to you, Christine.
Thank you so much, Sam, and completely agree with all of that. Now I'd like to turn it over to Dr. Ashley Page Atkins.
Thank you, Christine. Thank you, Sam. I'm going to go ahead and share my screen. Okay, so I'm going to provide introductory context about the new Transboundary Groundwater Resiliency Research Network, and going forward, I'll refer to it as the TGRR network. So this network, as Sam mentioned, is funded through the National Science Foundation's Accelerating Research through International Network-to-Network Collaborations program. The TGRR network of network prioritizes, in line with ExcelNet's goals, both accelerating the process of scientific discovery for transboundary groundwater research, as well as preparing the next generation of researchers that will lead the future of this international work. Going now into some of the background that shaped the idea for this network of networks. As this audience is well aware, unprecedented transboundary groundwater depletion is a critical issue not just for our US-Mexico border region, but for regions around the world. So understanding why transboundary groundwater depletion occurs, how it can be changed within these complex and interconnected systems, and how decisions and policies can avoid unintended consequences and meet their intended outcomes is key to reversing or avoiding altogether the depletion of these important resources. This project is rooted in the idea that harnessing advances in data science and system science can help answer these questions in ways that have not been previously possible, and also in ways that meet the diverse needs and priorities of stakeholders. Later in the session, you'll hear more about the unique capabilities of system science and data science and why they're well suited for this work. There are three primary objectives that the network aims to achieve. First, these efforts will catalyze transboundary groundwater resiliency research to address transboundary groundwater scarcity. Second, the network of networks will together identify the capabilities of this convergence approach and determine key questions and fill critical gaps in knowledge and resources. And third, this network will support the development of students and early career researchers who are going to be leading the future of transboundary groundwater resiliency research. So why a network approach for this effort? As this audience knows, transboundary groundwater scarcity is an incredibly complex issue, and it can't be solved by one group or one individual. So establishing the foundation for transboundary groundwater resiliency research must be a collective effort that acknowledges existing work and stakeholder priorities. There have been decades of important research and work in this region that many of you have been deeply involved in, and this knowledge and insight is critical. The TGRR network will connect existing networks so that we can take what we as researchers or stakeholders or community members know and need and harness the capabilities of systems and data science to advance water research in a way that can meet those needs. The network is not just limited to the US-Mexico border region, and we hope throughout the course of the project to meaningfully leverage the strengths of networks throughout the world to improve exchange and outcomes for everyone involved. On the slide, I've listed some of the initial networks that are part of the TGRR network, and later in this session, you'll actually hear from Dr. Rosario Sanchez of the Permanent Forum of Binational Waters. And we hope that you'll all consider joining the TGRR network and spreading the word about it to your friends and colleagues. Everyone is welcomed, and the strength and impact of this network of networks depends entirely on our collective efforts. So while the activities for this network will initially take place over the course of the next 2 years, we aim for this to just be the beginning of years of work and connections that can lead to impactful and innovative transboundary groundwater research. On the slide, I have listed some of the key network activities and future engagement opportunities. And some of the presentations later in the session will go into a little bit more detail about aspects of the activities. Each year, we're going to have an annual workshop, and these will be virtual workshops that are interactively focused. Every other month, peer mentoring and educational seminars will take place. This project will also produce an online course on TGRR system dynamics modeling that will be available to everyone. There will also be a lot of communication, exchange, and engagement activities and opportunities that will take place via the TGRR website, which we will develop throughout the course of the project. And additionally, there will be many volunteer and leadership opportunities for students and early career researchers. So the TGRR network's efforts, they are going to support existing and emerging transboundary water projects and work. And one of these efforts that we want to highlight is an upcoming virtual science conversation series. These conversations will be topic specific, informal, and binational meetings for researchers to get to know other peers and discuss their research. And these conversations will be focused on the Hueco Bolson, Mesilla Basin, Conejos Médanos aquifers. This is going to be an informal effort, and it's going to complement not just the TGRR network, but also the important formal work that's being done in this region. The first conversation is scheduled to take place in October, and these activities are going to run through September 2022. And I think Mark and Jeanette are going to drop the link in the chat to sign up to receive more information about these conversations. And we're also going to put the link in the chat to join the TGRR network and receive important updates. And just to conclude, we encourage you to join the TGRR network of networks, and we look really forward to your input throughout this process. You can go to the link listed on the slide or in the chat to register, and then further information will be sent out to everyone that registers throughout the link about upcoming TGRR activities and opportunities. And that's all that I have. And so with that, I'm going to turn it over to Dr. Saeed Langarudi.
Thank you very much for attending this session. My name is Saeed Langarudi. I'm a research assistant professor of system dynamics at New Mexico State University. Okay, what is system dynamics? That is exactly what I want to talk about today. Many of us have heard about systems approach or systems modeling for problem solving, but some of us may not be familiar with all the specific methods under this broad umbrella of systems approach. So here I will give you a very brief overview of system dynamics, which is one of the major systems modeling approaches. And we will discuss why and how this method is useful for transboundary groundwater resiliency research. System dynamics is a computer simulation method that deals with complex dynamic problems, especially those that involve human-natural feedback interactions. It's an elegant method for modeling dynamic phenomena by dividing all real-world variables into only two categories of variables, stocks and flows. From this worldview, all dynamic issues in the world occur through integration, and stocks and flows are sufficient to represent these integration processes. Stocks are shown with rectangles and flows with valves or faucets. Then there is an information connection between stocks and flows, which is shown by the arrows. Combining these simple elements, we can model almost any dynamic problem. System dynamics has been used in many different areas, including business, economics, public policy, environmental management, and so on. This method is usually used to explain and resolve problematic dynamic behavior, such as instability, like political instability or business cycles. Policy resistance is another place where system dynamics can add value. For example, we have seen declining groundwater levels in different places in the world in recent decades, despite continuous investments and efforts to preserve these valuable resources. System dynamics can definitely help with that. System dynamics is also used where we encounter complicated system behavior that is hard or expensive to track because of the complex feedback and long delays that are involved. The emphasis of system dynamics models, however, is on endogenous rather than exogenous causes. For example, to study financial instability, we usually focus on something like hiring policy, which is an endogenous driver, rather than market fluctuation, which is an exogenous cause. To study water scarcity, we can focus on management decisions, which is an endogenous cause, rather than climate change, which is an exogenous factor. However, we can, of course, study climate change with system dynamics as well. System dynamics provides a holistic interdisciplinary lens to complex problems, which is essential for transboundary groundwater resiliency research. Transboundary groundwater issues are hard to manage because they involve complex dynamic interactions, for example, between information perception and decision-making in different countries that share the groundwater resources. These decisions impact natural resources and social and environmental conditions, while the socio-environmental conditions also affect the decisions. System dynamics helps us to handle and track these complex changes and to better understand them. System dynamics also provides a common language for modeling and research, which is especially useful when the natural and technical language of the stakeholders are different. As I explained before, system dynamics models use a very simple visual representation that can serve as a communication medium for different groups of researchers and stakeholders. We can use system dynamics to test potential solutions in a safe experimental lab environment before implementing them in the real world, which can cause irreversible damages to the environment and economy. System dynamics is easy to learn, but hard to master. We need experienced system dynamics experts to help us develop reliable models that can provide a real insight. For that, we have already established the Water Special Interest Group, or SIG, within System Dynamics Society in 2019. We will leverage this important resource to expand our global network and connect with leading system dynamics modelers who are interested in water science and management. Our AxelNet funding that Ashley and Sam talked about enables us to augment and strengthen our current linkages also with big players in the field of system dynamics, including Worcester Polytechnic Institute, University of Bergen in Norway, State University of New York at Albany, and Sharif University in Iran. These schools train leading system dynamics modelers every year, and I believe we can tap into these resources and create a strong collaboration linkages with them. To build system dynamics modeling capacity within our networks, we have planned several activities. We will have 2 system dynamics modeling workshops where we will go through the basics of the method and some preliminary exercises. We will develop a system dynamics course on the topic of transboundary groundwater resiliency that will be available online and free for all members of this network. We will connect our members with the available mentoring and peer mentoring programs within the system dynamics communities. These connections will help our members to develop their system dynamics modeling skills. We will also try to provide opportunities for scholar exchange programs between the aforementioned schools. And finally, our members can also take voluntary or organizational roles in our connected system dynamics network, such as the Water SIG that I mentioned. So thank you very much. These are the references I used. With that, I pass this to Ilya or Christine.
Yeah, I'm here. Shall I share my screen?
Yes, please.
All right, so I'm going to talk about one additional component of TGRR projects, Transboundary Groundwater Resilience Research Network of Networks, about data science. My name is Ilya Zaslavsky. I'm a researcher at San Diego Supercomputer Center at UCSD and part of this project. So data science, I'm sure you have heard this term. It's a relatively new field and it's very popular. Because people collect more and more data, and it becomes very attractive to extract insights directly from the data and generate forecasts, sometimes more accurately than forecasts that we can generate from physics-based models. There are many techniques in data science. This field is not precisely defined. It's rather a general term for a range of techniques and approaches to extract meaning and value from large data sets and use it for a range of practical problems. There's a lot of data now available for aquifers as well, and we're very interested in exploring applications of data science to aquifers, in particular transboundary aquifers. This hasn't been easy for multiple reasons, because there are many data sets, but they are developed by different organizations on both sides of the border, and there are few established ways to share this data or to share analytical results from this data. Another complication is that modeling aquifers requires integration of multiple types of data that reflect geologic information, groundwater, surface hydrology, and other factors to model discharge and recharge flows. Next one. In addition, it's certainly a multidisciplinary problem, as we need to consider additional factors that are related to water usage and climate change effects, regulatory frameworks, local water practice and attitudes. And this is where system dynamics approaches and data science approaches can work together, because we need to look at this problem in all its complexity. So we have been exploring several examples of transboundary collaboration and examples of data science applications in groundwater. In fact, one of the goals of these projects is to assemble such examples to demonstrate how cross-country collaboration can result in better models and better decisions. One example is integration of groundwater information in the Great Lakes. That was a collaboration between USGS, United States Geological Survey, and Canadian Geological Survey. The goal was to integrate groundwater measurements across the border to build better models. And it was organized as a so-called interoperability experiment within hydrology domain working group of the Open Geospatial Consortium and the World Meteorological Organization, which is a group that develops international standards for water data. One of such standards is groundwater markup language. And it is a language that is designed to consistently describe components of groundwater discharge and recharge, such as different, so that different data sets can be mapped to a common model, and it will be technically possible to combine them into a single model. So groundwater markup language is now an official standard, international standards endorsed by Open Geospatial Consortium. If you have specific questions about how this standard works, I'll be happy to give you more information, because I was the co-chair of this group on the US side for 10 years. Another series of examples is, and these are also the types of examples that we're looking for. These are applications of machine learning and other data science techniques to groundwater and to aquifer modeling and forecasting. This first example that was published in Nature, here the authors compared accuracy of mod flow with 3 different machine learning algorithms for modeling groundwater dynamics. And they found that the accuracy of machine learning models was actually significantly better. The second example is an IBM pilot in several countries in south of Africa, where they looked at different artificial intelligence techniques to forecast discharge, and that also showed quite significant accuracy gains. In addition, we're trying to organize the examples into a set of learning materials that can be presented sequentially as a course. Something, probably many of you are teaching courses that are related to hydrology and groundwater, and now there's a lot of interest in using data science as part of such courses. So in this project, we will try to put together several modules that will help you when you work on these courses. We will build this over some existing spatial data science courses, because the general concepts would probably apply. What I show here is a chapter in the forthcoming book, GIS for Science, that is focused on teaching spatial data science, and that actually describes the course that I teach at UCSD to data science students. If you teach courses in groundwater hydrology that related to aquifers and have examples, please share them with us. Now, how you can share, there is a mechanism shown on the next slide. And here I would follow what Ashley just said. We welcome you to join this network and to contribute examples, your expertise, and just publish information about yourself so that others can find you and perhaps invite you into projects. And in this way, we can sort of build the joint expertise from both sides of the border that will help us address the aquifer challenges. You can go to this URL or scan this QR code, and you will be invited to fill out a survey where you will submit, information about yourself, and then immediately see a gallery of projects, experts, organizations, and networks that are interested in these topics. So with that, I'm finished with my part. I will be happy to answer questions in the discussion.
Thank you so much, Ilya. And let me say to you too, buenas noches and guten Abend. I know you're tuning in late from Germany.
Yeah.
I'd like to thank you so much for your presentation. I'd like to introduce Dr. Rosario Sanchez from the Texas Water Research Institute.
Thank you. Good afternoon. I hope you guys are not starving. I am. It's 1 p.m. here in San Antonio. So, but it's been very insightful all the whole morning. The thoughts, the comments are pretty current to what we are facing right now, not just in terms of water issues or challenges, but in terms of human and its relationship with its environment and what are we facing right now as a humanity. It's important that we acknowledge that at some point during our normal days and operations and the work that we do on a daily basis. It's important to remember where we come from and what do we want out of this. So thank you, Sam, thank you, Mark, everybody that was involved in this program. Alfredo, of course, Jeanette, the technical people that helps us. So thank you for the patience. Thank you for finally making this happen. I know it took you a couple of years to get this going on. So I'm very happy to be here and honored to be here. And with that, I'm going to follow up to give you an overview, quick overview of what the Permanent Forum of Binational Water is. Some of you are already part of this forum, some of you are not, but I think the work that you guys at New Mexico are doing is pretty aligned to what we are doing, and we can certainly be bigger together. While I was listening to what you are planning to do, what you've been doing on this NSF project, which is the data and data systems working, and us, and you'll see in a bit, working a lot with communities and the communication skills and the science diplomacy needs fits perfectly together to what we actually need on a complex issue as groundwater, and not just groundwater. The forum is really for everything that is related to water in the border. And this started over a year ago. It was an idea that we never expected that would reach that amount of people or that amount of interest to move forward. And I want to highlight that this was being able to be developed only because people believe in it. There's really limited funding on this. The people that work on this is pretty volunteer, and that speaks a lot of the need, of the interest, and the willingness that we are able to do if we just decide to do it. And with a little bit of funding, well, we can do marvelous things. I'm pretty convinced of that at this point. So what the forum is, or attempts to be, it's an effort to integrate and promote water cooperation efforts across the US and Mexico border. We are holistic, socialized, and science-based understanding of binational waters network scientists. And not just scientists, we have private industry, we have governmental officials from both sides of the border, we have NGOs, also part of the network, which is, and not just actually US and Mexico, we have people from all over the world also part of the network that is interested on the experiment, because I see this as an experiment, as a study case actually, that can be replicated or can be useful for other bigger efforts, as the ones that you guys are leading. That's why you have their global scale. Should we try to get this at a global scale? I think we should. I think we have the capability to do it. We have a set of values. We have a structure already on the forum. We have an advisory committee, an executive committee, binational. And we have over right now, I'm going to get back to this, but let me move to where we are right now. We have over 150 members in the border, experts and not necessarily experts in water issues, but working on water issues in the border, and 64 binational institutions partnering with us. 4 permanent programs, the coffee breaks, some of you are already familiar, the science talks, the facts and mythbusters, the open mic. And if you look at all this, it's really to facilitate communication. It's really to translate all those big numbers, all that big data that only a few of us, I won't count myself in there, are able to understand in lay terms. We try to translate. Okay, I'm going to ignore that. To communicate the science to the communities. We have learned, and I personally have learned that the biggest issue that we have really when it comes to science diplomacy is communication, is effective communication. And that's our motto. That's why I wanted to go back to it. What is transboundary effective communication? And this is what we have described as a social environment where individuals and organizations located in different geopolitical jurisdictions assess each other's verbal, written, and other forms of expression to evaluate whether they are trustworthy, respectful, and committed to their respective statements, principles, and values. There's a lot of words in here, but if you read it again on your screen, this is really big. I mean, it's really how we interact with each other, not just at a border-wide scale, along the border, across the border, is really what you want to accomplish, but you understand and you realize you can't do that too. We can do that alone, I'm sorry, but you can do that alone. And we need to start understanding that we need the other side, and we need all the sides at the same time. So in order to do that, you have to be effective. It's not enough to be right. It's not enough to have the science, to have the data and all that. You also have to be effective in communicating that information towards the people that you want to reach. Policymakers, authorities, communities, people that you want to understand what's going on out there. And that's really what is driving this forum towards what we want to become. Is really build on those initiatives and programs that integrate and incentivize people to be part of this. So quickly, we have 17 working groups already established. All our events, everything that we do is English and Spanish. And I'm sorry if I'm not speaking Spanish right now, but since this is, I don't know who the host is. I guess it's New Mexico. I should be speaking in English. It should be speaking in English, but I don't know. Alfredo, you let me know later. We are building a data set. Of course, we have over 500 scientific publications. We are working on, of course, on social media. If we are talking about communication, we have to get in that train, whether we like it or not. We have also databases that we give access to all our users, and public models as well. We have the Transboundary Water Portal, which is focused on only groundwater. We have that portal as well. Some of you are familiar with that. It's designed to share. It's designed with the purpose to share data. So we try to set the example in every research or publication that we have out there. Everything, all the data that it's used to have that, to be able to publish that, it's out there free, available to the public, because some of you know data, it's a problem. when it comes to groundwater. And data sharing is even a bigger problem at transboundary level. So we build that in that, but we have a couple of other models out there available to the public. We have the groundwater, what is this? The Binational Groundwater Task Force. This was the result of last year's Transboundary Aquifer Conference. And this working group is a task force, actually. It's pretty active. We meet monthly, and we're trying to identify priorities, develop work plans, or current challenges related specifically to groundwater. Of course, working on grants, proposals, and things like that to get some funding and some deliverables for this project. And I'm going to show you just briefly this because it's important in terms of our users, who is using this platform, because this is a platform. It was developed during the pandemic, so we haven't ever met personally. Everything that we have done is virtually, and it was developed virtually. So we are investing a lot on virtual services for our users, for members, and for ourselves, for our objectives. So we noticed that 60% of the people that are using the site are using the English version. And if you look at the countries that look at the search on the platform, we are pretty out there. I don't know exactly. We don't know yet exactly the ages and the Google Analytics behind all that. It's just the main information from the website. But you can see that we are trying to cover. It's reaching out there. We know it's 50% male, 47% female, which is good. We have a gender equity out there in terms of interests, and the age 25, 35, but then it's pretty standard between 30s and 60s. So it's important that we reach the new generations. And when Oscar was talking about what are we facing right now as compared to other centuries, and what's going on with our younger generations, and I was reading this morning that over 50% of young people, I would say 20s, 35s, are experiencing anxiety related to the environment challenges. That speaks a lot. The anxiety that we're facing right now, it's linked to a lot of things, but most of it, I think, is communication and how we communicate science to our younger generations, not just our GANs or preferred GANs, which all of you are here, but what do we want them to learn? How do we want them to manage the challenges that we are identifying today? What are we telling them? How to deal with them in the future? And a lot of this is, again, communication. And we have a lot of responsibility for those people, for those generations, younger generations, to make sure that, that anxiety doesn't take over and blocks them for the positive things of this, because I think this is all positive. I guess I'm a positive person, but this is good stuff. I mean, this is the way forward. It's not easy. It's not going to be enough, but it's the way forward, whether we like it or not. The people that are visiting the site are using our network. People are looking for people, and not just Texas looking for Texans, or Arizona looking for Arizonas or Sonoras. So it's people looking for people, working on the same issues on other parts of the border, and avoid to end up as an isolated effort. So what do we want? The forum has just become a nonprofit organization, which means we are trying to be sustainable in the long term and a little bit independent and grow on its own resources. So we're working on those operational structures and things like that. But on these specific projects, you'll see the Binational Data Hub. And I think that fits perfectly with the objectives that we've seen on previous presentations. And of course, build this forum as experience study case at a global scale. That's definitely what we want to reach. And we're building on a new platform. It's not ready yet, but it tries to be more, pro. That's the word that our website developer uses. In terms of vision, in terms of suitability for younger generations. So with that, I'm hoping I didn't get that much of your time today. The forum is for everyone, and we are happy to keep talking about this and how we can integrate efforts with the Excel grant that you guys have. I'm very, very happy for you and looking forward to work with you. With that, thank you.
Thank you so much, Dr. Sanchez. And not to worry, everything you said was automatically translated into Spanish by a live interpreter.
Thank you.
With that, I would like to introduce our last speaker, Dr. Eduardo Castillo. He's from the Centro de Inteligencia Artificial.
Thanks again. I'm Eduardo Castillo. I'm the director of the Center for Artificial Intelligence here in Juárez, Mexico. This center is an innovation center that was created by the state government in order to promote the technological competitiveness in our state, in the state of Chihuahua. So why create this AI center? We know that the data is the oil of the 21st century. This decade will close with 25 times more digital data than the last decade. We also know that we already have this opportunity of this digital economy, and entering this economy requires data management skills, technological infrastructure, and of course, artificial intelligence. In the World Economic Forum, in its report, The Future of Jobs 2020, have a forecast that in 2025, there will be 85 million jobs lost due to the division of labor between human and machines. But the good news is that more than 97 million jobs will be gained due to this same phenomenon. But these jobs will be required will require the digital skills. Skills like data analytics, artificial intelligence, machine learning, software development, big data specialists, etc., etc. So that's why we are focusing in creating a center which has this. Hold on, let me change which has this vision to be a driving center for a technological competitive community through a comprehensive model of continuous learning, innovation, entrepreneurship to promote this digital economy. And we will fulfill this vision by developing programs and action on this same strategic axis, focusing on generating applied knowledge while leveraging emerging technologies such as artificial intelligence, data science, blockchain, and other emerging technologies to foster technological competitiveness of the region and public welfare. We have this organizational structure. The center is organized taking into account a quadruple helix model where government, industry, academia, and society make up this non-profit organization. We have a lean organization structure composed of a general assembly of partners, an executive director, and 4 operational divisions as well. We also have these pro bono committees, with which we have interaction, and together we will carry out what is needed to drive innovation in our region. So how are we moving forward? We know that according to a study conducted by Forrester for IBM, there are 3 factors that affect the embracement and adoption of the so-called digital transformation in organizations. Data quality is one of them. And since data is the fuel of most innovations regarding AI and data science, we need to promote among organizations best practices for data management, avoid data fragmentation, and scale to strong data architectures. So we know that data and a good data architecture is one of the most important things to deploy AI and data science projects. Another factor is talent development, in which we as an innovation center are focusing a lot. I think that the lack of talent is affecting the rapid deployment of emerging technologies, in which we have AI, data science, blockchain, among other technologies. Here at the IA.Center, there are a strategy in regards to this topic. Since June 2020, we've been running a talent development program where we have offered about 56 courses with more than 4,000 students registered in courses such as data science, deep learning, machine learning, blockchain, and some other technologies. We even have a course on quantum computing. Our challenge is to connect these talents with a productive pipeline, at least in our region. And in that matter, we are working with industry to generate together innovation programs where they can benefit and establish a path to digital transformation. The other factor, or the last factor, is trust in decision makers, where we are facing in regards to this technology adoption. We should educate them with a clear understanding of how technology can create value for the organization. So that's why we came up with this operational model, which involves our three strategic axes of continuous learning, innovation, and entrepreneurship. We have structured this, the first pillar, into 3 levels. The first is the basic level, which aims to develop computational thinking and STEM skills for children K5 to K8. And with this, hopefully we will have a new generation of citizens with digital skills. The second level is an intermediate level, which is focused more of kids up to K-12. We seek here to develop programming skills, Python skills, as of we are running this program in this year. And the aim here is to have youngsters with a focus on engineering and technology. The third level is advanced level, where we involve higher education and professionals. The issue here is, or the main objective is to skill, reskill, and upskill all the workforce, and to have a talent pool for innovation projects, where we can involve in this innovation and applied research strategy. So this second pillar of innovation and applied research is focused on high-tech use case development, leveraging this talent pool that comes out of our talent development programs, and ultimately helping organization transition to digital business. And the third pillar is entrepreneurship, which aims to develop high-tech startups by leveraging all the innovation and talent development programs in the first 2 strategic axes. So these are some numbers, or some results of our talent development programs we have run since June 2020. As I said before, we've had 4 calls for training, in which we have had 56 courses with a 33% of efficiency, which give us like 1,300 or so of individuals that have already some sort of specialization in big data, applied data science, machine learning, deep learning, blockchain, Python programming, and some others. So some of the resources that we have are the following. We have a 2,000 square meter building in which we have 5 co-work areas, seven training spaces, 1 meeting room, 6 offices, and 1 data center. This data center hosts a computing cluster for AI and data science, in which we have a hybrid multi-cloud computing cloud platform capable of up to 45 teraflops processing and 360 teraflops tensor processing units. We also have this 10 gigabit internet connection. And lastly, we have this innovation laboratory from Microsoft that are deployed here in Mexico. There are only 3 of these laboratories. One is in Tuxtla Gutiérrez, Chiapas. Another is in the Universidad Veracruzana. And the last one is here in the University of Juárez, UACJ, but it's hosted here at the Center for Artificial Intelligence. So far, with these numbers and this short period of time that we've been operating, we have a couple of innovation projects in which we involve the environment. The first one is this project of Apply AI in Juárez, in which we developed a deep learning model to classify and identify and account all the trees that we have here in Juárez. We did this in partnership with Juárez Limpio. Some of the collaborators were Victor Herrera and Nestor del Castillo, and the other guys. We integrated a team from the IA.Center here in Juárez. The other project is this innovation project on precision agriculture with data analytics that we are doing with Dr. Alfredo Granados, Dr. Rafael Corral, and other researchers from the UACJ and the IA.Center here in Juárez. You know a lot more than I do about this precision agriculture topics, but the problem here is to optimize the use of water in a farm near Ascension, Chihuahua. So this project is running right now, and we are using some data analytics from Microsoft in order to achieve some results. So what are the next steps? We already have some binational collaborations with the universities like Purdue, UTEP, Sandia National Labs. Last week, we had this symposium on big ideas. It's called the Big Ideas for USA-Mexico Border Prosperity. The first theme was about sustainable manufacturing, but we also had topics of precision agriculture, water management, and some others. We are always open to collaborate and share resources and capabilities to develop AI and data science projects with any organizations. That's all I have for now. And I'll leave you my contact information if you wanna keep in touch or send an email or add me to LinkedIn. That's my information. Thank you.